In this video, I'm going to talk about how we understand interactions, which I also call effect modifiers, and how we do them and what we do with them and why we do them. So we're going to go back to our example with the farm. So we have some crop yield and we have fertilizer added, and that's a numeric variable, and we have 3 seed types. You can recall in our original model, which is written down below, we had the effect of fertilizer and we had the effect of each of the seeds. And we got these like 3 parallel lines. So didn't matter what seed type you were using, the effect of fertilizer was the same for each of them. But what if the effect of the fertilizer is different for different seeds? Maybe some seeds were made to work with the fertilizer, or the fertilizer was made to work with a certain seed type. So this is where effect modification can help us answer this question. An effect modifier is basically when you multiply 2 covariates together. So in this case, I've added 2 terms, one for seed B and one for seed C, where I've multiplied them by fertilizer. When you fit it in R, you put a little star, right? Like you do a multiplication symbol between the 2 things that you want to interact. So you can have things that interact and things that don't by putting like a plus for other stuff. And then the things that you want to have an interaction, you put a multiplication symbol between. You can see here in the output, I have my estimated betas for this model. The last 2, you'll notice, it says fertilizer : seed type, seed B. So those are the interaction terms. Looking at how the model works, if we have seed A, you'll see that the coefficient for beta 2 goes away because that seed B is 0, that indicator. The indicator for seed C is 0. So all the terms disappear except for the beta naught and beta 1. So the slope for seed A is beta 1 and the intercept for seed A is beta naught. For seed B, right, you can get rid of everything that has seed C, but the other things stay. If I regroup, I can see that I have an intercept, which is beta naught plus beta 2, which is the intercept for seed B, and then beta 1 plus beta 4 is the slope for seed B. So it gets its own slope. Beta 4 is the difference in slope between seed A and seed B. So it's the difference in the effect of fertilizer. That's why it's called an effect modifier. For seed C, same thing. So now, looking at the plot of these models, you can see that the slope is different for different seed types. If I was going to go interpreting these coefficients, I'm just going to go through quickly what they mean. Beta naught now is the intercept only for seed A. So it's the expected yield for seed A when you have 0 fertilizer. That's how we're going to get the beta naught by itself. To get beta 1 by itself, we need to make all the other things like go to 0, and then we still just have to have 1 seed type, right? Seed A. So it's the average difference in yield between 2 plots, or between 2 sets of plots that differ in 1 pound per acre fertilizer, which are planted with seed A. So for seed A, when fertilizer is increased by 1 pound per acre, then yield is going to go up by beta 1. For seed B and for beta 2, it's probably easier to interpret if you do beta naught plus beta 2 than just beta 2 by itself, but I'll show you both. So beta naught plus beta 2 is going to be the intercept for seed B. So it's the average yield when there's no fertilizer added to plots with seed B. Beta 2 by itself, well, to get beta 2 by itself, I have to compare it to seed A. So it's the expected difference in yield comparing plots with seed B to seed A when there's no fertilizer, right? If I had added fertilizer, then I couldn't have gotten rid of beta 4. So before we would say that it's the expected difference and it didn't matter what fertilizer is, but now it does. Finally, the slope. This one is really tough to do if you isolate just beta 4. So it's easier to think of it as beta 1 plus beta 4, which is the average increase in yield for an additional pound per acre fertilizer when you have plots with seed B. Right, it's the slope for seed B. I'm going to isolate beta 4 just so you can see what it is, but then we're not going to talk about it. And I'm not going to make you deal with it, right? Because it's either the increase or decrease, depending on whether it's positive or negative, in the effect of fertilizer compared with seed A. You'll recall that seed A had a slope of beta 1. So if we compare how fertilizer is affecting seed A to seed B, the difference is going to be beta 4. So let's go back to our question. Is the effect of fertilizer different for seed A and seed B? Well, to see if the effect of fertilizer is different, we could compare the beta 1 to the beta 1 plus the beta 4, right? So if beta 4 is 0, let's go back and look at these things. If beta 4 is 0, then the effect of fertilizer is going to be the same. So that's what we're going to test. So looking at my output, I'm going to go and I'm going to find my beta 4 coefficient. And I find the p-value for this test is 0.03. So that's significant. So at the 0.05 level. So we could say that we conclude that the effect of fertilizer is different for seed B than for seed A. I do want to show you one more example, and in this example, I have an interaction with two continuous things. So remember I added temp in the last example? Well, here is temperature. It's a numeric variable, and it has a minimum of 70 and a maximum of 90 and a median of 80. And so these plots are now held at different temperatures as well. So in this one, you can see how I've done a little interaction between the fertilizer and the temperature. So this is asking, does fertilizer work better at certain temperatures? And then I have plus seed type. So seed type doesn't have an interaction in this one. And you can look down and you can see fertilizer and temp. And that's because temperature is numeric. So it only gets like one covariate. It doesn't have a bunch of them. It's really hard to understand unless you pick values of one or the other. So you either pick values of fertilizer or values of temperature. I already have the summary statistics for temperature, so we'll look at that one. Since beta 5 is positive, that would mean that increasing temperature will increase the effect of fertilizer. Right? So the effect of fertilizer is going to be the beta 1 plus the beta 5 times the temperature. So let's look at how that goes. So I'm going to take my effective fertilizer, which is 675, and I'm going to add to it the effective temperature times the temperature itself. And that's for the median. Yeah, that's the median of the temperatures. So you pick some values maybe of temperature that are sensible to plug in. So this would be the effect of fertilizer when the temperature is 80. I can also look at other temperatures. So this is the effect of fertilizer when temperature is 70. So I'm doing this maybe for a couple values just so I can see. So I chose the ones that are in the summary table, so the minimum, first quartile, median, third quartile, and max. And you can look, I made a little plot of it. So you can see that as the temperature increases, the slope slightly increases. And then because there's no interaction with the seeds, the only difference is that the plots go up and down.